you all to today's class. And as we all can see today, our topic for today is calculus. Under calculus, I'll be teaching you guys differentiation. So for those people that don't know how to differentiate, don't worry, just calm down. I'm going to teach you how to differentiate by using the first principle. But take note of this. The first thing we must know the meaning of the y, the x. Okay, I'm going to teach you how to what? To find the y, the x. The next one is the process of finding the gradient or slope of a curve is called differentiation. I know some people don't know this. We call it what? That's what we mean by differentiation. When you are finding the gradient or the slope of a curve, it's called what? Differentiation. So the first one, we are going to differentiate just like what I told you, using the first principle. Look at the question here. Find the derivative of y equals to x squared from the first principle. So how can we differentiate from the first principle? Let's start with this one. Number one, if my y equals to x squared. So how can we differentiate this from the first principle? Y equals to x squared. The first rule states that you add y to where we have y. You add x to where we have x. It's governed by rules. So we have y, we're changing y, equals to x, we're changing x. Okay? Then you square because of this square. So we have my y plus changing y equals to, you need to expand this. Are you aware that this means x plus changing x, then x plus changing x? Okay? X times x is x squared. And, okay, let me break it down better, in a better way. Because it might not be clear to some people. X into x plus changing x. That method I wanted to use, some might be difficult for them. So let me use this other method so that it becomes easier. X times x is x squared. S times changing s will give you x changing x. Okay, ds times x will give you x changing x. Then ds times ds will give you ds squared. Okay, please take note of that. So this is x squared plus 2x changing x plus the x squared. Okay, so I'm going to write it here. So this is x squared plus 2x changing x plus the x squared. I believe it's clear to everyone. The next step is we subtract y from both sides. Differentiating from first principle is governed by rules, so you must know the rules. We are through with the first rule, we are going to the next one. So let's subtract y. Subtract y from both sides. My BS means both sides. So we have y plus changing y minus y equals to x squared plus 2x changing x plus changing x squared minus y. I believe that one is clear to everyone. So 1 minus 1 will give us 0. So I have my changing y equals to x squared plus 2x changing x, okay, plus my dx, my changing x squared, don't forget. Then minus y. What is y? Y is x squared. So minus x squared. I believe it's clear to everyone at this stage. So x squared minus x squared will give us what? 0. So that means this is out because x squared minus x squared will give you 0. So my changing y becomes 2x changing x, okay, plus the x squared. The next rule states that divide both sides by changing x. So let's divide both sides by changing x. Don't forget. So we have changing y divided by changing x equals to 2x changing x divided by changing x, okay, plus changing x squared divided by changing x. As you can see, these can cancel this. ds here 1, ds here 2, remove one of it because it's x squared. It can cancel one of it. So we have changing y divided by changing x equals to 2x plus changing x. I believe we are getting it, and I so much believe everybody can see that it's easy and it's very easy for us to get. And another observation is follow the rules. Once you follow the rules, it becomes more easier for you. From where we stop here, we said, therefore, our changing y divided by changing x equals to this. I want to write it again for everybody to see. Into 2x plus changing x. Please take note of this. For you to make this one to become the y dx, you must limit it towards 0. So you limit changing x to 0 so that it can become the y dx. Because we are interested in the y, knowing the dy dx. Okay? So my dy dx equals to 2x plus, which means anywhere you see changing x, you write what? 0. plus 0. So my dy dx equals to 2x plus 0 will give you what? 2x. So everybody can see that differentiating from the first principle, that is very what? Easy. It's very easy to solve. It's just for you to follow the rules. Let's solve another question using the first principle so that you can understand what I've done. Okay? And please don't forget, look at this. We said y equals to s squared. And I said the first step is you are changing y to where you see y and changing s to where you see x, as you can see. And that is why you are saying y plus changing y. Y plus changing y equals to s plus changing s. You know this is square. This one is carrying what? Square. So, and I said y plus changing y equals to, we need to expand this. I explained the other time. So after expanding this, we will get this. So the next we say that you subtract y from this side. So I just subtracted y from here. I've done the same here. Okay? This one, I wrote it and I subtracted my y. And if you observe, 1 minus y will give us what? 0. So that was why I wrote my changing s equals to s squared plus 2s changing s plus the s squared minus y. What is y? Y is s squared. That's why we are seeing the s squared here. So my changing y equals to 2s changing s plus the s squared. Divide both sides by changing s. That is the next rule. Follow the rules. Divide both sides by changing s, which I have done here. I divided it by changing x. I also divided this one by changing x. I also divided this by changing. You must obey the rule. Changing x, the s can cancel the x. The s here 1, the s here 1. The s here 1 in 2 is what? To remain 1 because it's the s squared. Okay. Changing y divided by changing s equals to 2s for changing x after the division. Okay. So, and I decided to write it again for everybody to see. So, the next stage is for this one to become the y dx. You must limit your changing x towards 0. So my dy dx equals to 2s plus 0. And 2s plus 0 will give you 2s. So differentiating from the first principle, as we all can see, is very, very simple. So let's solve another question using the first principle. Okay? We are going to solve another question by using the first principle. The first one we just did, I believe is clear to everyone. And I believe we are all following the rules. Okay? You can be easy when you follow the rules. So question number 2. What if you have y equals to 1 over s squared? How can we solve this? Follow the rules. The first rule says, where you see y, you add changing y to it. Don't forget our rules. And where you have x, you add changing x to it. Don't forget the square, you add a square. So, from this level, the next step is subtract y from both sides. Now, still remember our rules. Subtract y from both sides. Up is squared. We want to subtract y from here and from here. So we have y plus changing y minus y equals to 1 over x plus changing x squared minus y. Okay? I'm subtracting y from both sides. 1 minus y will give me 0. So I'm left with changing y equals to 1 over x plus changing x. Okay? Squared. So what is y? From here, y is 1 over s squared. 1 over x squared. And as everybody can see, we can simplify this. Let's break it down. So it's going to be, the s here will be s squared into x plus changing x. I've not changed the question. We just want to simplify. Okay? The s plus changing x squared, if you cancel this one, it will be left with this one. Times 1 will still be s squared. I believe that one is clear. We have minus. S squared cancel s squared, so we are left with this. You open x plus changing x. Okay, square. I believe it's clear. This is my changing y equals to this. I believe this one is clear. You find your s here. Okay, this cancel this, we are left with this. And times 1 will give you s squared. S squared cancel s squared. You are left with s plus changing x squared. Times 1 will still give you this. So let us break it down. I believe you are following the steps. And I believe it's clear to everyone. And if there's any part you think you are not fully got it, you can see go back and you observe from the way I'm explaining that it's easier. So we need to break this down. Let's break it down. Okay, let's come this side. Our change y equals to s squared minus, if we expand this, I've taught you how to expand that question before. We did it the previous time. When I started the first question, this was, when you expand this, it will give you this. Okay? I taught you how to expand. For those that cannot expand, all divided by s squared, open bracket, s squared plus 2x, changing x, plus the x squared. And I believe it's clear to everybody up to this stage. So I just expanded what from here. I expanded this x squared changing x squared and it gave us this. So let's open the bracket for everything. So my change in y, as you can see, equals to x squared. This is minus x squared. Minus times plus is minus 2x changing x. Okay. Minus times plus again minus the x squared. Okay. All divided by s. Okay. Let's open the bracket here. So x squared times x squared is x raised to the power of 4 plus 2x raised to the power of 3. Because x squared times 2x will give you 2x raised to the power of 3. Changing x, don't forget, plus x squared times the x squared will give you x squared, the x squared. I believe it's clear. Okay, I just use this to open this bracket. Okay, and from this stage, x squared minus x squared will give us 0, as everybody can see. So we are left with minus 2x changing x minus the x squared, all divided by x raised to the power 4 plus 2x raised to the power 3 changing x plus x squared, the x squared. Everybody can see. Okay, if you observe, please. We have the s here, we have the s. That means changing s is common. So let's make it as a relative formula by breaking it out. Okay? So by changing s, I want to bring it out, changing x. Okay? So here we'll be left with minus 2x minus changing x. You know, this is squared. If you cancel 1, you know it will remain 1. Okay? All divided by s raised to the power 4 plus 2x raised to the power 3 changing x plus x squared plus x squared changing x squared. The next rule states that divide both sides by changing x. Okay, so we have changing y or changing x equals to changing x into minus 2x and changing x. Okay, close the bracket. Then divided by, don't forget, by x raised to the power 4 plus 2x raised to the power 3. Are you seeing it? Changing x plus x raised to the power 2 changing x squared. Don't forget we are dividing by x. So divided by changing x. Don't forget. So this can cancel this. Okay? So I believe we are all getting the process and the method that is needed for us to follow. Because you must follow the right step to make your work more easier. Don't forget this cancel this. So what is remaining? Let's write it out. So my changing y over changing x equals to, we need to write this out, minus 2x minus changing x, all divided by this, which is x raised to the power 4 plus 2x raised to the power 3 changing x, don't forget, then plus x raised to the power 2, then changing x squared. So remember, for this to become the y dx, that is another rule which we must follow. So we must limit our changing x towards 0. So from here, let's take note of this. This cannot become the y dx because I want to limit changing x to 0. So my y dx now equals minus 2x minus 0. Then divided by this, x raised to the power 4 plus 2x raised to the power 3. Don't forget changing x is 0 times 0 plus x squared times 0. This is square, it can be 0 squared, depends on you, but times 0 is better. So my y dx equals to minus 2x, as you can see, all divided by x raised to the power 4, 2x raised to the power 3 times 0 gives 0, x squared times 0 is 0. So this is what is remaining. But you can still break this down in case you don't know. My dy dx here, minus 2x means minus 2 times x. Okay? X raised to the power 4 means x times x times x times x. If this cancel this, so we are left with our dy dx will now remain minus 2x times x times x is x raised to the power 3. You can see this side to write it as minus 2 into x raised to the power minus 3. So this is going to be our final answer for this question. So finally our dy dx is minus 2 x raised to the power minus 3. If you write your answer this way, you are still correct. Please take note of that. If your answer is minus 2 divided by x raised to the power 3 is correct. And if your answer is also dy dx equals to minus 2 x raised to the power minus 3, you are also correct. So this is how to differentiate from the first principle. But let me just remind us again. This is the question that you are given. The first will state that you add y to where we have y, and change the y to where we have y, change the x to where we have x, which I have done. You can see it here. But this one is currently square, that's how you are seeing this square. Then the next will state that subtract y from both sides, and which I have done. I subtracted y from it. I'm also subtracting y from it, because it's from both sides. And y minus y will give us 0. That's how we are going to change the y. And this is the question here. Then y is 1 over x squared. This is 1 over x squared. So my change in y now equals to. So the next thing I decided to do was to find the LCM of these two. Okay? And that's what I've done. I found the LCM of the s squared of x plus changing s squared, and s squared is s squared, and bracket s plus changing s squared. If s plus changing s squared cancel this one, we left with s squared. That's why you are seeing s squared here. And if s squared cancel s squared, we are left with this. And that's why you are seeing it here. And if you look at it, properly, I decided to break this down by expanding it. Okay, when I expanded, this is what it's going to give us. I taught you when I was solving it the first time, I taught you how to expand. So this, you must expand it, and this is what I've done here by expanding it. So next thing is for you to open the brackets. So this is minus s squared, minus times plus is minus. Minus times plus is minus. You can see I've opened the bracket. S squared times s squared will give s raised to the power 4. Then plus 2s raised to the power 3. Because s squared times 2s will give you 2s raised to the power 3 changing x. S squared times the s squared will give you x squared changing s squared. So as you can see, s squared minus s squared will give you 0. So that's how we are left with minus 2x changing x minus the s squared. Okay? Divided by this, which is s raised to the power 4 plus 2s raised to the power 3 changing x plus s squared the s squared. If you observe, the s is common to them. Okay? That's why I brought it out. And if you bring it out, if this cancel this, you will left with minus 2x, and if you cancel one of these, it's still going to remain 1. The next rule says divide both sides by changing x. Okay, which is what I've done. I'm dividing both sides by changing x. Okay, so this cancels this, so we are left with this. So my changing y become minus 2s minus changing x divided by s raised to the power 4 plus 2s raised to the power 3 changing x plus s squared changing s squared. So now, for this to become the y dx, you must limit changing x towards 0. So my dy dx now equals to minus 2x. This the x now is now what? Is 0. All divided by s raised to the power 4. We have the s here, so 2s raised to the power 3 times 0. We have the s here also, plus s squared times 0. So minus 2x minus 0 will give you minus 2x divided by s raised to the power 4. You know why? 2 raised to the power 3 times 0 is 0. S squared times 0 is 0, so it's of no use. So we are left with s raised to the power 4. But you can see breaking that. Okay? My dy dx is now minus 2 times x divided by x times x times x times x, which is minus 2 divided by s raised to the power 3, because x cancels x here. So we are left with s raised to the power 3. And you can also rewrite it as minus 2x raised to the power minus 3. This and this, they are the same. If your answer is this, you are correct. If it's this, you are correct. And now, you all can see that differentiating from the first principle is very simple. All you need to do is just obey the rules, follow the right steps, follow the rules that I just showed you. Please subscribe to my channel, subscribe to watch more videos. In our next episode, I will show you the different way of differentiating using different principles, using quotient rule or using product rule. I'm going to teach all using the function rule. In our next episode, I'm going to teach you. God bless you. Keep on subscribing. Bye for now.